Good day, good day, good day. Welcome back to our YouTube channel. So if you're new here, my name is Stifler. Please don't forget to subscribe if you enjoy our content, right? So today we are on vectors, grade 11. We'll be dealing with vectors, how to add vectors, and so on and so on. Everything about vectors, right? So welcome, just enjoy the topic, right? So in physics, we are going to be dealing with a number of quantities, right? So we are going to be dealing with quantities like force. We are also going to be dealing with quantities like distance, displacement, velocity, mass, acceleration, momentum. Don't worry about momentum for now, it's a grade 12 topic. And we're also going to be dealing with quantities like also maybe temperature when you get to maybe tertiary level, when we're dealing with topics like dynamics, thermodynamics, you'll be talking about temperatures. And we are also going to be dealing with a number of quantities, right? So these quantities that we deal with in physics, they are not the same. They are quantities that don't need the direction, right? Just like distance. So distance, no direction is needed when we're talking about distance. And also mass, no direction is needed. Also temperature, you cannot say this temperature is 5 degrees to the left or 5 degrees to the north or something like that. So no direction is needed, right? So such of these quantities that don't need direction, as you learned in grade 10, these quantities, they are called scalar quantities, or some may say scalar. Also, it depends on the way you pronounce. As for me, I say scalar. So these are scalar quantities. So when we're dealing with scalar quantities, there is no direction that is needed, right? So we can talk about someone weighing or someone has the mass of 20 kgs. We don't say 20 kgs to the left or 20 kgs to the right. So these are scalar quantities. But when we're talking about force, force now is a vector quantity. So every time we are dealing with vector quantities, you discover that direction is always important. So obviously, when a force is applied to the object, we are also interested in knowing like which direction is this force applied to. Is it applied to the left or to the right? So is it left or is it right? Then we can understand vectors has directions. So also displacement, it is a vector quantity. Acceleration, it is a vector quantity. Velocity, vector quantity. Because when we name the velocity, we can just say this car is moving at 20 meters per second to the left or to the right. So it means that direction is important here. Also, when we're talking about momentum, direction is important. So please, 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 please take your time with this vector topic, because this vector is going to unlock your thoughts on vectors and how you add vectors, how you subtract vectors, how you find the resultant vector, and so on. So today I'm not going to go into deep about this topic. I'm just going to be talking about this simple stuff about vectors. Then the next topic, I will deal with vectors into depth, how to really calculate vectors, how to really deal with vectors, right? So also momentum, it is a vector for those that just revisited this topic for the sake of grade 12 to understand deeper. Momentum is also a vector quantity. Acceleration is also a vector quantity. So what do we mean about direction? So direction is going to play a bigger role in this topic. So always remember, when you are dealing with vectors, always remember direction is very important. But since we just said this is a vector quantity and that's a scalar quantity, one may ask, what is a scalar and what is a vector? So we can describe a scalar by saying a scalar is a physical quantity with magnitude only. So this is magnitude only. We cannot say this person has the mass of 20 kgs to the left. It's just 20 kg like that. So 20 is the magnitude, right? It has the magnitude only, while a vector quantity is a physical quantity with both magnitude and direction. So this topic on vectors, what we are really interested in is to find the resultant vector. So what is a resultant vector? So a resultant vector, you can define this in two ways. You can say that a resultant vector is the sum of two or more vectors acting upon a single object. Or you can say a resultant vector is a single vector with the same effect as two or more vectors acting upon a single object. So when you are dealing with the sum of all the vectors, we'll be talking about vectors that are acting upon a single object. So let's get just straight to it and see how we add the vectors, right? So in grade 10, we learned a couple of stuff on vectors. So every time we represent a vector, we can represent a vector either graphically or we can represent a vector algebraically. So firstly, we'll be talking about a graphical representation of vectors. So once they tell you that a vector is acting upon an object and this vector is to the right, it means that this vector, we are going to represent it with something like this. So something like this will mean that this is the tail and this is the head of the vector. So this is the tail and this is the head of the vector. So at the tail, it is where the vector is coming from, and where there is the head is where the vector is going to. So it means that the head kind of shows us the direction of the vector. So this is the representation of the vector graphically. So this is how we represent vectors like that. So in grade 10, we used to do vectors in one dimension. So it means that we used to do vectors in a straight line. So when we are dealing with vectors in a straight line, graphically, we used to represent this like that. So we used to draw something that is called a vector diagram. So it shows the direction of the vectors that are acting upon a single object. So in this case, since we are going to be doing Newton's laws next, so it means that the vector that we are going to be talking about, mostly it is force. So we are going to talk about force as a vector. So this topic, we are going to be talking about force as a vector. So suppose we are saying that we are having an object like that, and we are having two vectors acting upon this object. So we are having a force being applied to this object. Suppose this is 5 newtons to the right, and we also have another force acting on a single object again, which is maybe 4 newtons to the right as well. So all these forces are going in the same direction. So to represent this, we used to do a head to tail method, right? Head to tail method, or tail to head method, right? So what it means is that we are going to draw this object, maybe represent it with a dot like that. So to represent this graphically, it means that this first vector or this first force, maybe let's say this is force 1, this is force 2. So it means that this is representing force 1 as our 5 newtons and force 2 as our second vector like that. So to find the resultant, since we said the resultant is the sum of 2 or more vectors acting upon a single object. So to represent this graphically, it means that to find the resultant, we draw or we connect the tail of the first vector to the head of the last vector. So mostly when we are representing this graphically, we need to draw this according to scale. So it will mean that our resultant vector now, it will come off from the tail of the first one to the head of the last one. So this is our resultant vector, or since we are talking about the force, so this is our resultant force from this point to that point. Can you see that this is the sum of this and that acting upon a single object, or we can say this is a single vector having the same effect as 2 or more vectors acting upon a single object. So this is how we represent that graphically. So let's take a look at some of the examples as well when we had different directions. So now suppose they say that the first vector or the first force acting upon this object, it is 10 newtons to the right, and the second one, it is 3 newtons to the left, like that. So to find the resultant, it means that we must connect the head to tail method graphically, right? So it means that this vector is going to connect from the head of this and remove 3 newtons left. Since this will be drawn to scale, it means that to find the resultant, we move from the tail of the first to the head of the last vector. So this will be our resultant. Can you see that? So it means that our resultant is just moving from this to that. So our resultant will be something like that. So this is our resultant force or our resultant vector. Since I said in this topic we'll be talking about force as a vector, so this is our resultant force moving from the last the first vector to the head of the last one, like that. So it means that its direction is that way as well. So suppose we're having a different situation again. Maybe we're having a situation where the force, the first force, so F1, maybe it is 5 newtons to the right, and we're having another force which is force 2, which is 7 newtons to the left, right? So to find the resultant, obviously we have to first show this by the first force. So this is F1, which is going to the right, and then force 2 will connect on the head of this, but it is going where? To the left. So this will be kinda longer than that. If we have drawn this according to scale. So now to find the resultant force or the resultant vector of this, as I said, so this is F2, which is going to the left. So now it means that we are connecting from the tail of the first to the head of the last. So this is our resultant force or our resultant vector, like that. So this will represent the resultant moving from the tail of the first one to the head of the last one, like that. So how about if we are having many vectors or many forces acting upon a single object as well? So still we apply the same thing. Maybe now let's try with 4 vectors or 4 forces acting upon a single object in a straight line. Like we said, this is vectors in 1 dimension, the one you were doing in grade 10. So suppose they said we are having the F1 as 3 newtons and we're having F2 as 5 newtons and we're having F3, so F3 let it go that way, as 6 newton, and the last one is F4. So most of the times if you are representing a vector, just put an arrow on top to represent that this is a vector. So suppose this is saying 10 newtons. So to represent this graphically, like I said, we connect the tail to head method, right? So firstly we start with this one, the F1, which is 3 newtons, so F1, and we connect this to the head of that. So that will be 5 newton as our F2, and F3, as you can see, it is going that way, so we connect its tail on the head of the first one. So F3, 6 newtons, and the last one is F4. So F4 will be equals to 10 newtons, like that. So now it will mean that our resultant will just move from the tail of the first one to the head of the last one. So this will be our resultant force just from here. So it means that if these forces act upon a single object, their effect will be just equivalent to this short one that is just going to the left. So that's our resultant. So this is how we were showing this graphically. So let's move algebraically. How do we show the vector, right? Nothing hard, still simple, and actually it is way more enjoyable if you are dealing with this algebraically, right? So now we're not talking about the representation graphically. That's where direction is most important. It is very, very important, right? So suppose they say we are having a F1 which is going to the right of 20 newtons, and we're having F2 also going to the right of 13 newtons, right? So since these are acting on a straight line, so nothing is complicated yet. We are not dealing with the 2D yet. It is still vectors in one dimension, right? So if you want to represent this algebraically, it means that we need to choose the direction, right? So in this case, you can choose our right as positive, right? So it means that our left becomes negative. So our right is positive, our left is negative. So now how do we represent this? We can say our resultant vector or our resultant force, since we are talking about the forces here, will be equals to, we said a vector, the resultant vector, let me just say resultant vector is the sum of two or more vectors acting upon a single object. So how do we represent that? Since we're having two vectors or two forces, it means that our resultant becomes F1 plus F2. So now what do we have? We're having force 1. Since it is going to the right, it is positive. So that's positive 20 plus positive 13. So this gives us 33 newtons, which is positive. So this is to the right, just like that. So this method doesn't matter how many forces or how many vectors we are having. We can be having a situation like this. They can say that we are having force 1, which is 30 newtons up, and we're having F2, which is 22 newtons up, and F3, which is 16 newtons down, and you can have F4 as 5 newtons down, and you can have F5 as 13 newtons up, and you can have F6 as 52 newtons down. So all these forces are acting on a single object. So how do we find the resultant? So still the resultant, we said it is the sum of two or more vectors acting upon a single object. So now we are dealing with up and down. So it means that we can choose the direction and say up is positive and down becomes what? Negative, right? So it depends on how you choose your direction, but at the end of the day, you still find the same answer, right? So what is the resultant vector? We said our resultant vector. So since we are having 6 forces here, it will be F1 plus F2 plus F3 plus F4 plus F5 plus F6. So now let's check our forces there. F1, it is going up, so it is positive, so this will be plus 30 plus F2 is 22 up, so it is plus 22 plus, and F3 is 16 down, so our down is negative, so that will be negative 16 plus, and this is down as well, so it's negative 5 plus, and our F5 is 13 up, so plus 13, and then plus, this is down, so that's negative 52. So now this means that this is 30 plus 22 minus 16 minus 5 plus 13 minus 52. So if we add all that together, we can find 30 plus 22 is 52 minus 16 minus 5 plus 13 minus 52, and you can find negative 8 newtons. But this negative is telling us something. So this negative is telling us the direction. So negative means down. So it means that this can just simply become our resultant vector being equal to 8 newtons downwards. So this is a single vector having the same effect as two or more vectors acting upon a single object. Maybe let's try a last example before we can call it a day, and the next time we meet we'll be talking about vectors in 2 dimensions, since now we are having a background of vectors in 1 dimension in case you forgot. So now suppose, let's say they said we are having maybe 4 vectors, which F1 is equal to 10 newtons to the right, F2 is 6 newtons to the left, and F3 is 10 newtons right, and F4 is 3 newtons left. So again, we will choose the direction. We will choose the direction. So since now we are talking about left and right, so you can choose maybe our right be positive, our left be negative. So if you want to try it, you can try it, and I'll give you the solution in 3, 2, 1. Okay. So now we said, what is the resultant vector? We said it is the sum of 2 or more vectors. So whatever it is, we are going to make a sum, right? So F resultant, since we're talking about the forces. So this is F1 plus F2 plus F3 plus F4. So to start with, you just say plus, 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 and then you deal with the different directions later on, right? So F1 is going to the right, which we said it is positive, so that's positive 10. And F2 is left, so that's negative 6. F3 is right, which is positive 10. And lastly, this is negative 3. So this would be 10 minus 6 plus 10 minus 3. So putting that in your calculator, we are going to find it as what? As 21 newtons. So therefore, it means that our resultant force will be equal to 21 newtons to the right, since it is positive there. So that's how we do vectors algebraically, right? So I hope you enjoyed this small section that we did today. And if you haven't subscribed, please just rush to subscribe. And we are going to meet on the next time when we are dealing with vectors in 2 dimensions. And I promise that I will make you enjoy this topic, and I will make sure that I will make you never to forget this again up until tertiary level, right? So don't forget to subscribe, like, comment, and share. Until then, I'll see you on the next one. As I said, my name is Stifler. Goodbye. Have a lovely day.